most preppers will spend their entire lives preparing wrong. They will buy land. They will build structures. They will pour concrete. They will spend decades and tens of thousands of dollars constructing what already exists. Right now, in every city and town across this country, there are buildings sitting empty. Not just empty, engineered. Engineered specifically to solve the 6 core infrastructure problems that will kill most survival groups in the first year of collapse. These buildings are not hidden. They are not hard to find. They are visible from the highway. They sit on the edge of every town. Most people drive past them without a single thought. Those buildings are abandoned factories, and almost nobody in the prepper community understands what is actually inside them. Not the obvious things. Not the shelving or the square footage. The 6 specific systems built into the structure itself. Systems that require no power, no maintenance, and no money to access. Systems that took engineers decades to design and contractors years to build. Systems that directly address water, power, security, food storage, structural defense, and waste management simultaneously. The prepper who finds the right factory finds all 6 solutions in one location. The prepper who ignores factories will spend years building inferior versions of what was already there. Here are the 6 things inside every abandoned factory that turn any empty building into a self-sufficient compound. Understanding this requires understanding what factories were actually built to do. A factory is not just a building. It is a self-contained operational environment. It was designed to function continuously, independently, and efficiently without external support. Before modern utilities became reliable, factories solved their own problems. They collected their own water. They generated their own power. They controlled their own climate. They managed their own waste. The infrastructure that made that possible is still inside those buildings right now. It did not leave when the workers left. It did not disappear when the machines were removed. It is embedded in the floors, the walls, the roof, and the structural skeleton. Most of it is invisible to someone who does not know what they are looking for. Most of it is completely intact, completely functional, completely free. The collapse scenario that destroys modern infrastructure does not touch these systems. They predate modern infrastructure. They were designed to operate without it. When the grid fails and municipal water stops, the factory systems still work. They work because they were never dependent on the grid in the first place. This is not a theory. This is engineering reality. Sitting in plain sight, here is exactly what you are looking for and exactly where to find it. Number 1. The roof-mounted rainwater collection infrastructure. Walk to the exterior of any abandoned factory. Look up. Industrial roofs are not flat by accident. They are engineered drainage systems. Every large industrial roof contains a calculated slope network directing water to specific collection points. Those collection points connect to internal downspouts running through the wall cavity. Those downspouts were designed to move thousands of gallons rapidly and efficiently. The original purpose was stormwater management, preventing flooding of the production floor. The collapse purpose is something entirely different. A standard industrial roof collects between 0.5 and 0.6 gallons per square foot per inch of rainfall. A modest 20,000 square foot factory roof collects over 12,000 gallons from a single 1-inch rain event. That is more water than most survival groups can store, transport, or find elsewhere. The collection infrastructure already exists. The routing already exists. The drainage points already exist. Your only task is redirecting the existing downspouts into storage vessels at ground level. No construction required. No engineering required. No tools beyond a wrench and a connector fitting. The factory solved your water collection problem before you ever walk through the door. A group with access to this system never needs to source water from external locations again. That single fact eliminates one of the 3 primary causes of collapse-era group failure. Number 2. The compressed airline infrastructure. Every factory that ever ran pneumatic tools has compressed air lines running through it. Those lines are typically steel or copper pipe, 1 to 2 inches in diameter. They run through the ceiling, along the walls, and drop to floor-level connection points throughout the entire building. The compressors that fed those lines are usually gone. The lines are not. What remains is a complete pressurized distribution network embedded in the structure itself. This infrastructure has 5 specific collapse applications that most people never consider. First, the lines can be connected to any external compression source, including bicycle-powered compressors. Second, existing line segments can be repurposed as water distribution pipe throughout the building. Third, compressed air stored in salvage tank vessels connected to this network powers pneumatic tools indefinitely. Fourth, the pressure differential in the lines can drive simple mechanical systems without electricity. Fifth, sealed sections of the line network function as pressurized dry storage for seeds, documents, and sensitive materials. The pipe itself is worth more than most people carry out of abandoned industrial buildings. Copper compressed air lines represent hundreds of feet of highly useful material in a single factory floor. Steel lines represent structural and fabrication material, usable for dozens of construction applications. You are not just inheriting a pneumatic system, you are inheriting a materials inventory. Most salvagers take the machines and leave the lines. The lines are the more valuable asset. Number 3. The electrical panel bypass architecture. Every factory contains a main electrical service panel, usually multiple sub-panels. In collapse, those panels appear useless. The grid is down. There is nothing feeding them. This is incorrect. The panels are not useless. They are waiting for a new input source. Industrial electrical panels are designed to handle significant amperage from any source. They do not care whether power comes from the grid or from a local generation source. Solar arrays, wind turbines, salvaged vehicle alternators, and water-driven generators all produce usable current. The factory panel is already sized, already wired, and already distributed throughout the building. Connecting a local generation source to the building's existing panel feeds power to every outlet and fixture simultaneously. You do not wire a building, you wire one connection point. The factory distributes from there. This is the difference between lighting one room with a battery and lighting an entire compound with the same input. Locate the main service entry point on the exterior of the building. This is where utility power originally entered. This is also where your alternative power source connects. The internal wiring does all the remaining work. You inherit an electrical distribution system for free. A building that took licensed electricians months to wire is already wired and waiting. One connection replaces months of labor and thousands of dollars of material cost. Number 4. The loading dock ceiling and defensive architecture. This is the system most people recognize, but almost nobody thinks about correctly. Loading docks were designed for one purpose: controlled access for large vehicles and cargo. They have heavy steel roll-up doors. They have reinforced concrete aprons. They have elevated platforms. In a commercial context, that is logistics infrastructure. In a collapse context, that is defensive architecture. Heavy steel roll-up doors are among the most difficult barriers to breach without heavy equipment. A standard industrial roll-up door is 24 gauge to 26 gauge steel. It stops small arms fire. It stops improvised breaching attempts that defeat standard doors in seconds. Multiple loading docks on a single building create multiple independently controllable access points. Each dock can be sealed, monitored, or opened independently based on threat conditions. The elevated dock platform creates a natural defensive high ground over any approaching vehicle or group. Someone standing on a loading dock has a significant positional advantage over anyone approaching at grade level. The concrete dock construction is not penetrable by vehicle ramming at standard road speeds. Most defensive compounds spend enormous resources on barriers, gates, and hardened entry points. The factory provides all of that without a single modification. Walk the loading dock perimeter of any industrial building and you are walking a pre-built defensive line. The engineers who designed it were solving a logistics problem. They accidentally solved a security problem simultaneously. Number 5. The overhead crane structural anchor network. Most abandoned factories retain their overhead crane rail systems even after the cranes are removed. These are heavy steel I-beam tracks mounted to the structural columns at ceiling height. they run the full length and width of the production floor in a grid pattern. The original purpose was moving heavy loads horizontally across the floor. The collapse application is something else entirely. Those overhead rail systems are load-rated structural anchor points, spaced every few feet across the entire ceiling. Each anchor point is rated to hold thousands of pounds. That rating does not expire. What can be done with a distributed ceiling height anchor network throughout an entire building? Suspended sleeping platforms that keep occupants off the ground and away from ground-level threats. Hanging storage systems. They use vertical space and keep supplies out of flood range. Pulley-based material handling that allows small groups to move heavy objects without powered equipment. Interior partition mounting points for dividing the space into functional zones without construction. Tension-based defensive systems that create interior barriers, deployable and retractable on demand. The overhead rail system turns the entire building into a three-dimensional usable space. Most collapse shelters operate on a single plane, the floor. A factory with intact crane rails operates on 3 planes simultaneously. This multiplies the functional square footage of the building without adding a single structural element. A building that appears to hold 20 people comfortably holds 60 when the vertical space is utilized. The rails are already there. They are already rated. They are already mounted. Number 6. The subfloor drainage network. Every factory floor contains a subfloor drainage system. Almost nobody talks about this. Industrial floors produce fluids, coolants, hydraulic oil, wash water, condensate, processed liquids. Those fluids cannot pool on the production floor. They degrade the floor and create hazards. So every factory was built with a drain network embedded below the concrete surface. That network runs to a central collection point, usually a sump pit or a municipal connection. In collapse conditions, that drainage network becomes something far more valuable than a floor drain system. First, it is a complete gray water management system requiring zero construction. All wash water, cooking water, and non-potable liquid waste routes away from living and food storage areas automatically. This eliminates the sanitation problem that destroys most survival compounds within the first 3 months. Sanitation failure kills more people in collapse scenarios than violence or starvation combined. The factory solved the sanitation problem with a system already installed beneath your feet. Second, the sump pit at the collection point is a below-grade temperature-stable storage chamber. Below-grade temperatures remain stable between 50 and 60 degrees Fahrenheit year-round. That is the precise temperature range for long-term food preservation without refrigeration. Most root cellars are dug specifically to achieve this temperature range. The sump pit already achieves it. Third, in facilities built near water tables, sump systems sometimes access groundwater directly. A sump that reaches groundwater is a manual well, requiring no drilling and no equipment. Map the drain lines. Locate the sump pit. Understand what you have before you begin any other modification. The subfloor drainage network is invisible, undervalued, and more important than any other system in the building. 6 systems, all pre-existing, all functional, all free. Water collection from the roof. Pneumatic and material infrastructure from the compressed air lines, electrical distribution from the panel architecture. Defense of structure from the loading dock design. Vertical space and anchor points from the overhead crane rails. Sanitation and cold storage from the subfloor drainage. No survival group can build all 6 of those systems from scratch. Not in time. Not with the resources available post-collapse. Not with the labor of a small group. Every factory provides all 6 simultaneously in a single location that is already standing. The preppers spending years constructing a compound from raw land is not ahead. They are behind the person who finds the right factory and understands what is already inside it. There are over 300,000 vacant industrial buildings in the United States right now. They are not waiting to be repurposed. They are already repurposed. They are already repurposed. They just do not know it yet. The difference between the group that survives the first year and the group that does not is rarely weapons. It is rarely food stores. It is rarely training. It is infrastructure. Specifically, who has it and who is still trying to build it. The factory has already been built. The only question is whether you find it before you need it or after. After is too late.